gonna start on the visualization part 2, and we're gonna squeeze in some libraries in this session too. So I'm gonna try to be as brief as I can. So in the previous session we looked at the decorators, which were tied to a specific panel or widget or visualizer. The naming is not completely clear always. This time we want to look at a panel and more specifically a visualizer. So it's technically or practically what we're displaying on the main canvas. And you've already seen the meta decoration or visualizer. So as we can see, it has a completely different context in this sense, and it displays not even the data that we're looking at when we look in the composition and where we see the model as that. So the way visualizers work is that we register them on nodes again. So we're gonna abuse this language node again. And if we look at the meta, we can see that the valid visualizers is the model editor, the meta aspect, the crosscut, the graphis. It's not very easy to read there, so if I open up the node, we can see that we can view it in different visualizations. So if we move it to the graph view, we can actually view it as a simple graph. Right now, there's no grandchildren, so we can navigate further. And we can edit the behavior, so we can say that for this language node, we only support the model editor and the graph visualization. So if we load it again, at this point it only displays them here in the visualizer panel. And depending on the order, it will use the first one it encounters. So what we're going to do now, or partially do, is we want to define a visualizer for a simulator, a state machine, and that visualizer should look up the current model and see what it contains and build up a simple graph. Then it should look at the simulator code that's attached, and it will embed it as an iframe, and within that iframe it will have its own global scope. And if you remember, when Scholt opened up the program or the index, it had this simulator class defined. So once we attached it in this iframe, we'll scope it, and then we will access the simulator class. And from that, the idea is that we should be able to make a GUI for that simulator class and display when we transition between different nodes. So keep in mind that in this case we could have generated the code on the fly from the model without using the plugin, but we want to show how you can get updates in your model or in the territories you define. But we also want to show that you can attach results coming elsewhere, and you can, like running a plugin, you can pre-generate the result, and then you can attach it to your model and basically pre-generate the result. So what we're going to start out doing is we're going to generate the template code for the visualizer. So again, we use the WebGME CLI tool, and we want to create the new, and the visualizers go under VISD. So a new vis, we can look at the arguments, and we can see that it takes a visualizer name. And we're not going to make a secondary one, we're just going to set the ID. So if we look, the argument is visualizer ID. And we're going to call it as much as FSM simulator. So again, it created these templates codes under FSM simulator panel, and it also tells the server that this visualizer is now available, so it edits the configuration. At this point we can start the server, and then we go back to our source and we can see that there's a new directory under visualizers. So the visualizer consists of 4 parts. So it has a descriptor called visualizer, which basically describes the ID and the title and where the panel that defines this visualizer is available. And this is used by the visualizer panel here. When it's populating it, it knows where to actually load the file when we're switching between these. So the main class describing a visualizer is the panel, and what it does is that basically it ties the widget and the control, and the widget is the distinction we try to make is that the widget deals with the graphical or the HTML handling, and the control deals with mapping data to and from the WebGME model, and passing it to the widget. So we're not going to go into details of all it does. So this is some boilerplate. It gets the client from the outside, so we know we have access to that. It initializes a widget. It initializes or the widget and the control, and it says that it's activated. It registers on, or it provides some methods that will be invoked from the outside when it's being resized, and when it's destroyed, when it's activated, on when it's deactivated. That means if we're moving away from we start editing things in the property editor, for instance, then the main canvas is temporarily deactivated. And once we go back, it will be activated. So this class we can actually leave as it is. We're not going to edit it. Instead, we're going to exit the presentation mode. And we're going to look at the controller. So within the scope of these 30 minutes, I'm going to try to write the control, but I'm not going to attempt on finishing up the widget for the visualization. We will need to copy that. But we'll make sure that we extract all the data that is available and that we need for the current model. So if we look at the control, it's again a class-like function, or this is the constructor, and we see we have access to the widget and the client. For this visualizer, we're interested in what the current node ID is, so where is the active node, and by the active node is meant the node that is being, or from the view of the composition, which is I guess the most intuitive, the active node is the ID that is being opened right now. So right now the active node is 2. When we open up this copy, we change the active node, and you can see that the part browser listens and modifies itself based on the active node. So that's a main thing, or an important concept, and we'll go through here. This will basically register for click events on the widget. So when we click something on the widget, so we will have to look at the widget in order to see what this actually does, but it will allow us to, when you click on a node in this widget, it will register that as the active object. And if you see here, the counterpart of the composition is that when we double click, we register for a new active object, and we the visualizer adapts and displays the content of the active object. And another example is when we navigate up, this also sets the active object. So that is being registered, and we can register on that event from the WebGME global, and we can also set the state, the WebGME global state, sorry, from that. Before I go into this function, I'm just going to show the way it's hooked up with this. So when we're being activated, we do attach these listeners, and we can see in the WebGME global state that on the change of the state active object being changed, we call our method state active object changed. So we register for that event. And when we're being activated, we're starting to listening to those events. And in case we actually switch the node between activations, we will register that active event. The code down here is for the toolbar. I'm not going to cover that, but visualizers can add their own items on the toolbar. We can see it. So more importantly, so when we get the event that the active object was changed, if it's the same node, we're not going to do anything. But if it changed node, we're going to call this method, which is unfortunately named wrongly here, selected object change. So that is the active object has changed, and we need to adapt to the new context or to the new node. So the way it works, as opposed to decorators that were attached or were being controlled from the visualizer, and by default it already had access to the node that it was rendering because the visualizer took care of that part. As a visualizer, we have to make sure that whenever we're entering an active object or a context, that the nodes that we're interested in are being loaded. So loaded and accessible from the client, because that's not necessarily always the case. So the first thing that we do, I can also mention that when we're being initialized the first time, it will see this method would also be called. So we can think of it as the visualizers being triggered for a specific node. Now we know the active object, and then we want to find or make sure that we can get all the data we'll need. So in the case of our finite state machine, what we want to make sure is that we can get the children of that state machine. So we want to get the state and the transitions, because without them we can't find any information of how we should actually visualize them. So in case it was already there, we remove this territory or the UI. Here we edit the state, so we're saying, okay, right now the current node ID is the new node ID that we potentially got from the global state. And what we do, so in this example here, we define a set of patterns which will define our territory. So starting from the node that is the active node, the first rule says, okay, I'm just interested in that node itself and no children. So the territory rule has only one query, or if you will, or one parameter, and that's how many children starting from that node, how deep in the containment chain are we interested in. Then it will call the widget and set the title of that. That's some graphical things, and this is for the button that we were using. So if it doesn't have a parent, we're just going to hide that button. We're not going to allow users to navigate. And here we set the parent ID too for the new one. And more importantly, so what we do is we tell the client that we are interested in nodes and we want to register ourselves as a user or a UI. And whenever there are updates in our territory, we want this callback or event handler to be invoked with these events that the client will give us. I'll go more into detail about those events. At that point, we only register as a user. What we do next is that we say, okay, I have a defined territory. We pass our ID that we got when we were registered, and we pass in the pattern, and we tell the client to update that territory. So what happens is, in case the territory was new and there are nodes matching that territory, when the client will start loading those nodes potentially from the server, and when they're available, it will invoke our event callback that we defined as a user. In this particular case, it's actually done twice because we don't necessarily want to wait for the children to be loaded before we can display something. So at the very beginning, it will just be two different events. So the first event is for the simple territory, where we defined it up here, children 0, so only when that node is available. Then the second event will be with this augmented territory. It will contain, or it will be notified when the children down to 1 level has been loaded too, and it will trigger our event callback. So the first thing we're going to change, because the way we're going to do this model or in this visualizer, is we're just going to say that, okay, when we change the context, we'd like to load all the internals of the finite state machine so we can build it up, and we will pass the data that we extracted from those nodes into the widget, and it will create this graph for us. So we're going to simplify it simply, and we're going to say, okay, we're just going to have one territory with one children, and we're just going to update this territory once. All right. So get node descriptor, I will come back to that one. So as you can see, whenever the territory is done, it will call the method event callback, which takes an array of events, and it's defined over here. And I think the easiest to do here is we can actually put the breakpoint here, or we can log it. And then let's do the debugger statement. We can see that it's and at this point I don't think I registered the visualizer for the state machine. Maybe I did. No. So as I mentioned in showing the previous model, we registered the valid visualizers, and it works in the same way as the plugins, that we can set it on a base type, and then all the instances or subtypes of that node will have the same registration. So now we can see the available ones, FSM simulator. And if we go to our example and we open up one of these state machines, we have the simulator available. And what it does by default is that it's listing all the events that it's being passed from the controller. So the visualization is tied to the widget. So we can see that we have adding node and adding all of these. And if we go back, we close it. Now the debugger statement should be bad, so yes. And we can see that we get one callback or one triggering of this event, and it contains an array of events. So this basically says that this is not associated with an actual node. It's called a technical event, so it's not necessarily of interest. It's just that if we register for something that doesn't exist, we still want to get a notification that at least the client tried to load it, but there was nothing there. For each other one, we'll see that the events are associated with an ID. So this is the ID of the node and a type of event. So in this case, it's a load. So the load event is triggered when we first update our territory and we tell the client that load these nodes. And when they're loaded, we'll get back an event and a load event. In a similar way as with the decorator, like on add to, if we create a new node within that territory, it will also trigger a load event. So if I add one node, it should trigger a single event plus the technical one saying that this node was loaded. Then we have the unload, which is when a node is deleted. And then we have the update, which is again similar to the decorator update. So we're gonna let this one finish. Where's the play button? What we want to do is that we want to keep track of the initial load because we're only interested in our simulator what the snapshot of the model is. We want to be able to notify users if there are changes, but since the simulator code is tied to a commit hash or a specific revision of the model, we're not going to update the visualization based on events. So instead of going through here, we're going to make sure that we're going to add a new state within our controller, and it will keep track of if there's been an initial load. So in our controller, we'll add an initial loaded state. We say that's false in the beginning. And whenever there's a selected object change, so this is already guarded that if the node wasn't changed, it's not a new node. So in this case, we're going to reset it. So this is each time there's a new context, we're going to say, okay, it's actually not initially loaded, because we will remove what was previously there and we will add our new territory and invoke this update territory to get the initial load event. So what we're going to do when we get this event is we're going to check whether this is actually the initial loading phase. So if this initial loaded is false, we're going to load all the data. Otherwise, we're going to give back these individual updates. So saying there is a load, there is an update, there's an unload, and we will pass that to the widget and tell it to at least notify the user that the model have changed. So what we want to do, we want to build up a simple data structure, or the finite state machine data that represents the current node. So what we want within it is we will need how we can access the simulator code. In the beginning it's null. We want to know the descriptors of the nodes or the finite state machine elements. So when we get the initial load event, what we're going to do is that we're going to first set the initial loaded to false, or actually to true. So next time there's an event, we know that it's not the initial event we're interested in, it's actually another one, and we will update based on that. We're already seeing the events, so let's iterate over them. So if we use a for loop here, we have the events, we know it's an array. And since the state machine itself is contained, we actually want to treat it differently, because the descriptors will basically be how it's internally built up with states and transitions. So we will check if the event ID is the same as the current node ID, we'll do something different. Otherwise, we'll reuse this method. We've got to populate the FSM data, more specifically the descriptors, and we're going to index them by the event ID. So the event ID is the ID that you see in the client, or when the property editor, also referred to as path when we use a core. And we will call this get object descriptor, and we'll pass in the event ID. And when we're done, we will make a logger statement. All right, so if we go back here, again, the node library load is loading. So if we go inside this guy, we bring up the console. Okay, so now you can see that the decorator is printing messages. I forgot to register for our new simulator. So we're going to pass in a different string. We're going to refresh. And now we can see that the initial load event with the FSM data, so we didn't populate the simulator, but we do have descriptors gathered for each node, and we can see if it's a connection or not, what the parent is, the name, and I will show that method shortly. I just want to make one point. So as you notice, when I refresh, the current selected simulator is the FSM simulator. When I refresh it, it will set that visualizer too, and that's, you can see it's encoded in the URL. And not only does it set the visualizer, it also set the current node, which branch we're in, and which projects to be loaded. So that's why we can refresh and come back to the same context. It doesn't capture the full state, but to some extent. So I'm quickly gonna show this method. There it is. Okay, so at this point, there's a utility method that takes the node ID, and when we invoke it, we assume that the node is loaded because we invoke it when we get an unload event or an update event. So we're gonna get the actual node object from the client, and we use get node. But just in case, we're gonna make sure that the node is actually available. So if it's not, it's gonna be undefined, and it's just gonna return undefined, and we could check for that. So in the object descriptor, so this is a generic one which applies to any type of domain, like all have an ID, a name, and some children IDs. But here we can use the node object to gather more data about the node. So this node object is defined for the client, and there's not super well documented, but the source code is readable. So I'm not going to go into that because I'm starting to run over here. But the point is, at this stage, we would gather all the information we need from our domain. So if we know it's a transition or a connection, we want to get the source and destination. And if it's a transition too, we want to get the event property or attribute, sorry. And based on our domain, we will extract the data we need to visualize this, the graph for our state machine, and also hook it up with this simulator that we generated. So since we're running out of time, I'm going to exit the presentation mode, and I'm going to copy over the code. I'm going to grab the whole source directory. And I'm going to paste it. Okay, it should reload. So in this node, so from the graph data we collected, we can build up this graph using a simple SVG container from this visualization package. We will embed the visualizer, and if it's correctly, we should be able to initialize it, or sorry, the simulator. So in this case, we can initialize the simulator, and what it does is it uses the simulator class to get what events are available. When we initialize it, we're at the initial state. So from the data that the simulator generated, we map it back to the visualizer and we visualize it. So now we can enter a new event. So one of them was npm install. And at that point, it moves over to the other event. The simulator gives us the potential new events. We can type one that doesn't exist, and we're stuck there. So let's say that the testing succeeds, and then users notified, and go. And now we're at end state, so the simulation is over. In that case, we can reinitialize. So again, this code is checked in. Unfortunately, it takes longer to go through. So this was a brief introduction. But if you're interested in Visualizer, as a first step, I would study the generated one, and then you can see how we modify it here to hook it up with some more domain-specific visualization. So that's it for the visualizers. Questions?
Can you change the position in the composition view, or like the names of the objects, or add the new state and then switch back to the simulator?
So as long as we're reinitializing, we do get the data from the actual model. However, if we open up another branch or another browser, and we remove something here, we go back, it will only notify that the current model may have changed. So right, that was the visualizer. Any questions? All right. Thomas, do you want to proceed with the libraries?
Yeah, let's try to quickly wrap it up. So, so far we've seen how, let's say, typical workflow would look like. And whenever we think we are ready with our domain, we would like others to use it. And one way to do that is to compose multiple languages. And I would like to show you a way how it can be done. First on the UI, and then, if we have time, a small plugin example. So we will use the state machine we built as a library in a mother project. So let's start on that. We will create a new project. Now let's call it signal machine. And luckily the default content of the deployment has the signal flow system, so we will abuse that model. And our first step to brought in the library is that we, in the object browser, we right click on the root node where we can select the add library. Here we have to give a unique name, and then we have basically two options. One is that we use an exported package, project package, or we can use the actual URL of the other project. So let's do that. We just simply copied it. And voila. So the whole content of that project is now used as a library in our new composed project. As you can see, there are a few things that immediately show up in the pod browser. So here you can see that the namespace, or we call it full name, so namespace and then the name we used in the state machine. So that way you can differentiate between your own language elements and the library language elements. If there are too many elements, there's an option that you can just list the names of the nodes, but basically the drag and drop will work as the same. And you can select if you just want to see the objects or the elements of a given namespace. So once we have the library, we also have everything, as I said, that was there before. So even the examples, and as you can see from the logs, they are read-only ones, so we are not able to modify them. But if we would update the actual library model, like removing this state machine, then we would have the option to update it with a single click. It enables the refresh button because it detects that the library is an actual project, so it can follow that branch and check if there is anything new there. So that way we don't have to give again the URL or the package. And it will not update. So anyhow, it would update it. If not, you know how to write a GitHub issue and we will fix that. The other portion we would like to highlight with this library is that you're not only able to use it. So for example, if I go up in the composition, as we was seeing, the elements of the library already became available, so I can instantiate them, I can use them. But when you want to compose your languages, you want to extend your language definitions. So let's say we would like our primitives in this signal flow language to be able to contain state machines. To do that, in the usual way, we brought in the state machine element. It again shows that you are not able to modify that given element, but you are able to use it to define new rules for your own language. So let's say that the state machine can be contained in a primitive. And then if we go back to the composition, and we should have an example here, this means that once we are entering a primitive, we are able to create a state machine here. And as you can see, because all the wallet plugins, all the decorators, everything was set up in the library, they are already available for us to use in this new project. I hope, and yes, it works as well, because the UI will actually check within the context what would be the best namespace to execute that given plugin, so it will execute the associated code generator plugin within the FSM namespace. So we didn't even have to modify anything in our plugin to be still functional. And if we go inside, okay, let's not go inside here, but let's say we copy here our example, and if we go inside, the visualizer also works. So we can say, oh, so that's how on the UI you can leverage the library function, and you can use any number of libraries. If the state machine would have another imported library, it would show up here, and you can use the associated tools from that as well. And, yep.
Thomas, can you show when you invoke the plugin from the default play button in the left corner?
Yep.
Yeah.
So if the UI notices that you're using namespaces, then when you start up, it will add the global configuration to your plugin, stating that you are allowed to say that, okay, use the FSM namespace or don't use any namespace. Probably if we say that don't use any namespace, it will not function as we would like. Yes. But the point is that, as you can see, by default, it selects the namespace that the plugin is originated from, or basically the context node, the meta type of the context node is originated from. So right now it says the FSM. And if we execute, yeah, we can see the same artifacts that it created in the FSM project itself. All right. So now, um, so we will not have time for it, but in the code example, you can see that you can see a way how actually you can write a plugin that uses a plugin from a library. So there are different ways how you can manage it, but basically, again, it means that your boundary plugin would select the proper namespace for a library plugin, and then it's able to execute it, and it's able to use its artifacts and things like that.
Keep that stack trace.
Which?
The one in the terminal.
Yeah. So that was all for libraries.
Thank you. Can you go back to the slides, please?
Yep.
So I don't think so it makes sense to write more code today because everybody's tired probably, but just I give you like a 5 minutes recap and then we have an hour for questions and answers if you would like to ask more questions. So we started with an introduction that Peter did, and he presented the key concepts of WebGME, like a server and client application. You have seen a few example applications where sometimes the entire UI was replaced by the developers. Some people have created plugins. That's a really common thing to do. Or some others, like now, created several decorators to visualize the different contexts in a more meaningful or domain-specific way. Then we had the modeling session where we created a simple domain and the meta model for a finite state machine that used the default UI, the default visualization techniques. After that, we developed the plugin for the finite state machine to generate a simulator. So basically, the user can build any finite state machine instances, and we can generate the code that could execute that finite state machine based on the events that we are giving it to the machine. Then we created a custom decorator that extended the model decorator features, which added a new button on top of the box where you can invoke the plugin. So that showed an example how you can have a custom invocation point from the client for any plugin. It's especially useful if you create your own UI. Then it's also indicated whether an up-to-date code or simulator is generated or ready to use for that specific state machine. And finally, Patrik showed the visualizer, which is a domain-specific visualizer that took the object and visualized like as just basically circles, as states. It preserved the layout of the model that the user built. It preserved the connections and the names. And within the browser, you could execute that plugin you could execute that state machine that the user built by initializing the state machine and entering the valid events between the states. And then Tamás showed briefly how to use and reuse these domains and provide it for others as libraries. And the key point here, compared to the old GME, you get the meta model, you get all the example models, you get an automatically assigned namespace for all of your concepts. Then you can compose these predefined meta models from the library with your domain, and all the tools, including plugins, decorators, visualizers, will work as you would be inside that domain. And what we didn't show, because of the time, we ran out of the time, if you create a plugin for your integration language, you can call out to the other plugins that were already implemented, and you don't need to change a single line of code. Most likely just reuse those plugins and generate some artifacts from the models in that context. So thank you very much for coming. I noticed that there were more people here in the morning. Now there are less and less people, so before we lose more people, I think we would finish here. And if you have any questions or answers, all of us are here and we can help you to get them answered. Again, I would strongly suggest to check out our repository on GitHub. So if you go to WebGME/tutorials, each of the sessions has a snapshot of fully functional and working code. If you notice any discrepancies or you have suggestions for the readmes or to update the readmes, any pull request is welcome. So just send us pull request and we're gonna merge it in. So that was all for today, and questions now. Let's start there, Dimitri.
Since these libraries are so composable, is there like a centralized repository that they're being collected at?
No, but when you use the WebGME command line tools, what we do is you can pass the GitHub username and the GitHub repository, and it pulls all the plugins and seeds and everything into your project. So you can set it up as dependencies. So there is no central repository for domains. We have created a few domains, such as Final State Machine and P3nets and other common domains under the WebGME organization. And in fact, our WebGME.org deployment is composed of multiple domains in that way. So basically, you just use the command line tool and say that give me that domain, and it brings in the seed and everything as a dependency, and you can update it with an npm update.
What's the name of this?
And that's all.
So what do you do if you have a candidate domain that you want to submit and see as part of the central deployment, as opposed to advertise your unique address to people who are not?
Right. So you need to check in you need to check in the seed and the meta model along with all the plugins and everything to GitHub, most likely, and then you just send us an email or create an issue on GitHub saying that, oh, here's a domain that I would like to see on webgme.org, and I think that we have only a few rules or restrictions how you should maintain your repository to make it compatible, and we can pull it in as we have changes. So you need to maintain your code and repository probably on GitHub. That's the easiest way for us to pull it in and provide it for others.
So for a project, I mean, talking about these libraries, for a project that has multiple domains with kind of domain-specific plugins for each domain, yet there's an intersection, like sci-fi mail. Would some of those interpreters or plugins, could they be written in the domain-specific? If there's like a integration component or integration object that can contain objects from multiple domains, and then you can connect those in the integration world, how would you port a plugin? Like, because you're not actually connecting domain models, you're connecting them through an integration model. So do you understand the question?
Yes. So in the plugin, what you need to do, you need to prepare it for other unknown types that you will experience, right, during your model traverses. So that's one option. The other option, you have your own language to integrate them together, because if you have already created a plugin, you also have an integration language, how you integrate those models together in your domain. And you can have a model transformation in the integration language that translates it to your domain model.
Okay. So that's kind of a anticipated use case? Or?
Yes, it is. Benji?
Yeah, so I was going to ask, did you guys ever run into good candidate domains for what we used to refer to as meta-circularity? So when you essentially, so this is very different, so I'm still trying to wrap my head around it, but in the old GME, you built a language, a meta model, and you built instances of it, but those instances were in some cases, or the meta concepts for another set of users and another language, right? But
Right.
the old GME didn't have that ability. It feels like you could basically
Right. Yes, so we thought about that, and there is definitely a good use case for that in WebGME. So you have the atomic building blocks of your domain basically, and then you build more complicated or complex concepts using it, and you would like to provide it for others to reuse or for reuse, right? As a library, as an instance library, because that's going to become as primary building blocks for the other language or for the other users.
Yes, but
Yes.
I think there's a difference between the library in the sense that you share a language and instances that you might have created with it
Yes.
as reusable concepts versus when your instances in the library now could potentially become constructs in your language.
Yes. So what we were doing in the past few months is when we integrated the libraries here to the Part browser. The Part browser got extended now with the library concept, and it can be extended probably in the future with such concepts that you just said. And then it's going to be a primary concept here, and you can just drag and drop, even though it's not part of the meta, but it's something that you promote as first-class objects that you can use in the other language, right? So again, there is a path for that, but we haven't implemented that yet. And we are also talking about, for instance, model templates, when you have this complex structure and you would like to restrict it, that this can be replaced by any of its instance, and the constraint in class is itself. And that's a model template for somebody, and somebody has to fill it in with implementation. So there are several of these ideas that we haven't implemented yet. So during today, the live demos, I think there was only one thing that didn't work, which was the library update, but the rest of that is, I would say, stable. And the libraries were added to WebGME as the last release or last two releases.
And I think that the template also is a very interesting and potentially very critical component. We happen to use it a lot through the idea of references, and then when you create an empty reference, you can instantiate that model, but then later add in a reference because that's sort of the outside of the scope of
Right.
what's locked down in an instance.
Yes.
So in that sense, you can have an invalid element that is a placeholder that only when you fill out the template becomes actually a valid model.
Exactly. That's right. Any other questions? I think it's possible as you just described. So you create separate projects for each language, and then you have one project for the integration language, and that project includes all the other domains as libraries. And in the integration language, you have inputs and output ports, and create the workflow. You connect them together, and so that's exactly how you described it. So. Yes, so you have to, most likely you cannot avoid to write an interpreter or a plugin at the integration level, which would map those concepts. And how you execute it, how you manage the execution, everything, it's up to you. So is it like a co-simulation, a loosely or tightly coupled execution? Which execution engine do you use? Do you use independent execution engines, or that's completely up to the actual domain developer who develops that domain and the tooling for it.
So yeah, it's kind of the same. Who's using who then? Which? So you have an integration language, and you have, three other ones that are being integrated. Then, do you handle your mapping in the kind of child used domain, like the mapping between like an integration port and a domain port? Or is that outside this?
I would say it's up to the user.
Okay.
We provide
So
the
you can do it
framework
either
that
way?
you can use libraries and you can reuse these components.
Okay.
It's up to the user, and it may even depend on the domain.
Right.
You may not even want to use libraries.
Right.
Maybe it boils down to that, okay, I just want to put everything into my language because it's easier to do that. But so we had certain things that would help you to achieve those things. And sometimes the decorator is a good choice, sometimes the visualizer is a good choice, sometimes you have to completely rewrite the UI for that specific purpose that you would like to provide for the user. So it's going to be your choice. We give you the tooling and you pick which one you would like to use, or you can ask for help or suggestion.
This might be out of scope, but compatibility and integration with old WebGME models and interpreters.
Yes. Yes and no. So no, in a sense that the meta model is completely different because we have a single, something is a connection in this view because it has a source and destination pointer. So our meta model is more generic. It's a single object, right? We don't have connections, predefined connections, folders, atoms, and so forth. So I would say that if you...
So they're doing strong typing, you're doing depth typing.
Right. So I would say you asked about old models, old interpreters, desktop tools. Old models, usually what we did, if the meta model is, I would say, kind of simple, you can build it, you can rebuild it in WebGME to use the new concepts. It's easier than map it. We have also created at one point some kind of automated tool that mapped certain portion of the meta model to WebGME, but it became, the actual domain became unusable because that's not how you would like to represent things. And the tools, the interpreters, if they processed already a pre-generated XML file, for instance, or something like that, we would just suggest to write the JavaScript plugin that generates the exact same XML file for the tooling. So the interpreters are not portable as they are. And we also created in certain cases.
Is that poorly created or you can create it?
I think we have one which takes like an XMP file to be more specific and creates all of those concepts in WebGME for you. But it's not bulletproof. So
No, I misunderstood.
Sorry.
Do you have it the other way around?
we don't have any of these ways fully supported. So I would suggest if there is a new project coming and it's not using any of the old GME stuff and you like WebGME, just use WebGME from the very beginning. If you have old models that have to be ported over or you consider porting it over, either, you have to write some kind of tool that does the job. If you need a tool or you need to recreate the models or rebuild the models.
So what you're saying is you port the model, and this would be your recommendation, port the model from desktop.gme to WebGME, and then write a wrapper for your interpreters, presumably they're like in COM.
I would say you write, so in this case, for instance, the state machine, we created a JavaScript plugin, which was 250 lines of code. That's not a big burden. And generated a JSON file, or you can generate an XML file, and just feed it your existing tool. That's what Peter did too. He generated like a JSON or XML representation of his model, and he wrote the rest of the interpreter in Python. So he just coded out the Python and said that, okay, the Python takes this input file which is the representation of the current context or the model that I need for the Sumo tool that will do the traffic simulation for me, and it did the job because he was more familiar with Python, right? But still, that really thin layer has to be. We suggest it is in JavaScript. We don't have bindings to other programming languages.
And then can you talk about import? So if you wanted to mass import, say, from a database from a previous GME project, or what are the recommendations or options?
Again, it depends on the size of the data. I would say anything that is less than a few hundred megabytes, you can write a JavaScript plugin that will be executed on the server side and either give a file for it or a directory that read all the files from this directory, or a database access, or a URL, an HTTP URL, and it downloads the data from there. So that's how I would suggest to do it.
Do you guys have examples for that by any chance?
I think we do have importer and exporters, simple plugins that would run on server side and client side, and the input is a file. So we have an example of that. Nothing specific data. I know it's not a specific domain in the WebGME in that sense, but it takes a file as an input and builds up a WebGME model. Yes.
Is there an example which would just traverse all the nodes and create a JSON or XML representation?
Yes, so I don't think so we have an example, but core.load subtree, and then from each node you get the data what you like to have. That's what I suggest. So it's like you generate we have boilerplate code for everything, as you see. So you just generate a minimum working example for the plugin. We have several examples, and the load subtree is your friend in that sense. And you can start from the root. Keep in mind, if you have a million nodes, it will load all the nodes. And you just build up. We usually build up actually a JSON structure all the time, a JavaScript structure, and even serialize that into an XML. Either a template, or you also have a converter between JSON and XML. Other questions? Yes.
So say you started an interpreter that is running for a long time. Do you have an ability to tie that the execution and stop it in the UI, or would it be then a command line method to an access to the server to stop it?
Again, if it's a one-time import for a big data set, you can execute it from the server side. That's what I would suggest.
No, I meant
But
interrupt.
Interrupt the.
Yeah, so you're running
Sorry.
Often I give bad scope to the interpreter and it's running on a giant model.
Yes.
And I know it's a non-destructive method to this concept.
There's no.
No timeout. It used to have a timeout. Used to have a timeout on the interpreter.
But it,
No, you cannot. So right now you cannot stop the interpreter. So.
But you could add it yourself in your plugin.
But yes. So what Patrik says is that what is good, you can add the timeout in your plugin, which you expect that the interpreter finishes within 10 seconds or so when the main is called, and you just kill basically your process, so raise an exception or return early, and just stop the rest of the code execution. That could probably or potentially work. But
You can even configure it
so in this case, when you mentioned, for instance, run it on a big model or you're in the wrong context. So we registered this new plugin for this context. That's why the play button is enabled. And if you click on the play button, you can see that the interpreter is registered. But if we go inside one of the states, then that shows results. So you cannot even invoke the interpreter in an invalid node. that the interpreter cannot process. Yeah.
Not a user mistake.
Other questions?
Is there a copy and paste between functions, between projects?
No, not right now. No copy and paste in projects. Alright, if there are no other questions, I think that was all for today. I think we recorded both the screens and audio and everything, and we will put it up somewhere. I don't know where at this point. And you can reverse certain sections if you like, or if you get into decorators, you can just reverse the decorator session in the future. So this intended to be a tutorial for everybody, and I hope you enjoyed it.